Hello. Well, now listening to SoFun, I know I'm not going to lose my job anytime soon because SoFun, while good at talking, is not really good at talking. Hello, friends. Welcome to my part. I actually was surprised that it's me now. I thought I was at the end, but hello. Welcome to Agents Don't Ship Themselves. My name is Darko, and I have 10 minutes to talk to you about agents. First of all, we've all built agents, right? Show of hands, who built an agent? Look at that. Who used an agent? Everybody raises your hands. Of course, if you ever chatted to ChatGPT or Claude or whatever out there, it's an agent. It's a thing that does a thing. It's more than an LLM because it does, well, what is agent, right? It's AI, right? But it has a lot more features to it. It is something that does things autonomously. So whenever you go ahead and ask ChatGPT to check something out, it goes on the internet autonomously, pulls information, responds to you in a nicely formatted way. So in essence, we've all been using agents. And I saw a little show of hands who uses OpenClaw here, and not a lot of people. I was about to make a joke about stop buying Mac Minis, but I'm not sure if that's gonna fly today. But okay, so in complexity, when it comes to building an agentic system, it's very complex. It takes a lot of moving parts. So let me unfold this. There's agentic applications, and user input. But that's not all. There are components, tools, memories, runtimes, APIs, shell executions, code interpreters. All of these things exist as part of an agent. There's additional evaluation, making sure the agent does good, checking that the responses are fair, improvements, constant things. There's observability, there's databases, there's human evaluators. All of these things belong in an agentic workflow. When you build an agent that does a thing, you kind of have to do all of those things. So how hard can it be to build an agent right now? I must say, I built an agent back in 2023 using Rust, of all things, back then. It was hard, it didn't work, it was just a pain in, well. Today, to build an agent, it just takes that. There's more lines of code, but in essence, you need one line of code. Line 18 is all it takes to build an agent. That agent will respond to my messages, that agent has a tool, and that agent can do all of those things with a single line of code. So what is that? Let me show you. Here's a little video of me doing this in the past. And I'll talk about what Strands is in a second. So, piece of code. Python application with a single important line, number 18. It uses Bedrock, Amazon Bedrock as a model provider, and it has a tool called Calculator. It's literally a calculator. So I invoke that, and I will get a response of something, something, math. That's it. That's a simple agentic workflow in a single line of code. That's all it takes. And how does that all work? Well, it works with Strands. Strands is an SDK that was developed at AWS. It is not an AWS product, as you may think. It's an open source SDK for Python and, as of recently, for TypeScript, which you can use to build agents on whatever platform you want. Be that AWS, be that Anthropic, be that OpenAI, be that even a model running on Ollama locally on your workstations. It gives you access to tools, gives you access to workflows, to orchestrators, to memory, to runtimes, to shell, and a whole lot of things. It is incredibly powerful because it gives you access to create these models super fast and, well, a lot of flair. So let me show you an example how you can more than a single agent, right? I show you one agent that does one thing, it calculates numbers. What if there was two agents that are orchestrated by a third agent that does some research? Look at that. I'll show you some code in a second. So multi-agent, there's basically how this works. Defining two types of agents. One is a researcher. It has access to web browsing. It can do HTTP requests. The second one has access to a calculator. Slightly different prompts, that's all. Both of these models are wrapped inside of a function that's decorated as a tool. So an agent is just a tool call away that's being called by the orchestrator agent. That's it. So what I do is when I pass a prompt to the agent, to the orchestrator agent, I just tell it, research me the 15% of North Carolina population. And you will see a bunch of stuff happening here. It's going to invoke tool number one, basically the research agent. It's going to fetch a bunch of things from the internet. Once it's done, it's going to invoke the second agent, who's going to take that number, do some math, and apparently 1.5 million people, that's 15% of North Carolina. That was a very simple example of agents running locally on my laptop being orchestrated by a third agent. Simple, right? Well, let's go beyond localhost. Because I kept telling you, agents don't ship themselves. Your agents can run on your laptop, no problem. They can run on a Mac Mini, no problem. But actually, to get all the value for you and your customers from agents, you need to ship them somewhere. They need to run somewhere. And I think the cloud is the best place for your agents. So let's have a look. I want to talk to you slightly about a product we have called Amazon Bedrock Agent Core. This is the platform to run your agents on AWS. It has all the bells and whistles you need to give your agents the tools, the capabilities, the memory, the runtimes, the shell executions they need to do their jobs. We have customers like Ericsson, Cox Automotive, Thomson, and even Amazon Devices uses Amazon Bedrock Agent Core for a whole lot of agent orchestration, both internally and externally. So I'm going to give you a couple of code examples, a couple of these things in action running on Agent Core. So let's start with the runtime. This is where the agent runs. Again, no matter what model you choose, no matter what library you choose, like I'm going to be using Strands, but you can use the same thing with LangChain or even Crew AI or whatever. Agent Core supports all of those things. So Agent Core runtime is basically just an ability to run your agent somewhere. So let's have a look. I have here, I don't even remember what I have here. Okay, so I have a simple agent. It is, again, very simple. It's a Python file that defines which model, what agent, and what tools does it have. That's it. Define a single entry point. This is how your customers or other agents invoke this agent. I deploy it. It takes maybe a minute to deploy to, well, actually no, this is real time, so it's going to take a couple of seconds. It's going to be deployed to AWS using the Agent Core command line interface, or the SDK if you wish. As soon as it is deployed, you're going to be able to invoke it. And you'll see me invoking it with a simple payload. It's a JSON payload. I'm using the SDK, so the Agent Core here, Agent Core CLI, but you can use the SDK. You can just pass on an HTTP post request if you want. But in case I'm just passing on a prompt, what food should I try in North Carolina? First time in North Carolina, by the way. So hopefully we get something nice. What? Barbecue. I was told barbecue is really good here. So, but I'll be honest, the best food I had, the best pizza I had was in Durham. I don't know, so, yeah, Toro, yes. I lived near Italy, and I had better pizza here than in Italy, so there you go. But yes, I had an agent drop a bunch of stuff here. So, and this agent is not running on my laptop. It's not running on ChatGPT. It is a model on AWS, but it's being invoked by an agent that runs in the cloud. Simple as that. Sure, Darko, that's great. You ran an agent. Wow, whoop-de-doo. Okay, more. Let's talk about memory. This has been one of the things that is incredibly important for agentic workflows, especially if you have customer-facing agentic workflows. If you want your agents to remember your customer preferences, the facts about your customers, what's the last flight they took? Memory is critical. Being able to create memory between agent invocations or even long-term memory between different conversations is key to make them really work for you. So I'll show you an example where I create a memory and I store some information in memory with one agent. Then in the next round, I go ahead and, well, retrieve the memory. It sounds simple, but it is actually a complicated, because agents are by their nature, stateless. They don't know what's going on besides that context window. So I'm deploying, super fast sped up, I'm deploying a memory on Agent Core on Amazon. It takes like a couple of minutes. Once the memory is deployed, I'm going to show you how I store it. And again, I'm using Strands SDK, but this works with whatever framework you want to use. So I'm just defining which memory I'm getting from the environment variable, defining the memory configuration, just the memory ID and the session ID, and then just calling the agent with that configuration. That's it. I'm passing a bunch of information about myself, one of the reasons I didn't introduce myself, and then I'm calling it to store it. And you will see, nothing fancy happens here. The user doesn't know there's memory involved. It's just the model stores that information as it gets it from me, as from a user. So if you were booking a ticket or ordering food over an agent online, the agent would remember certain facts about you, that you prefer barbecue or pizza or flying to Nashville or whatnot. So, great. It has stored all that information about me inside of its memory. What I do right now is call a different agent, a brand new invocation, completely new. And I ask the agent to remember stuff about me, well, recall stuff around me. You will see it's gonna pulling this context from a shared memory. In a second, by the way, it takes like a couple of minutes for this memory to be collated, but yeah, look at that. It has pulled this information off from the memory. It has been able to do that across different invocations. This is incredibly useful, and it just runs on the cloud. I could have done this with a model running locally. Actually, this model is running locally. This model is not even deployed. So it's all running on my laptop, but the memory is in the cloud. Couple more things. I want to talk about MCPs. MCPs, there's a whole discussion, are they worth it or not? I think they're incredibly valuable, but MCPs are just resting on top of an API. So Agent Core Gateway gives you the ability to take your open API standard, Lambda or whatever, and just expose it as an MCP server. So if you have an API built, you can just treat it as an MCP server thanks to Agent Core Gateway. You can also do things like a code interpreter. Basically, you can run code in an isolated sandbox environment. Your agent can run code completely safe and secure if it wants to do something. Fantastic. Incredibly important for agents to be able to do really good things. Lastly, you can actually simulate a browser. This has been a very useful thing because not everybody has an API yet. But an Agent Core browser is an incredible, useful feature if you want your agent to do something on your behalf, like book a ticket or order Chipotle or whatnot. The best place for your agents is not on your MacBook. It's not on your Mac Mini. It is in the cloud. Your customers, yourself included, will thank you once you have a centralized agent you can talk to without having to rely on that, well, expensive GPU or that service running. So the best place is the cloud. I want you to take them there. Before I go, there is a workshop happening later today if you want to learn more about strands. A lot of stuff I talked about, my colleagues Jonathan and Rob are doing a workshop later today. You can screenshot that or take a picture of it. It's happening here. It's free. You should go check it out. And I want to direct you and your agents to connect with me through my blog. Thank you so much, my friends. Enjoy the rest of the show. Thank you.